All right, it sounds like we actually have a caller on the line.
Sweet.
so-
Oh, all
Hello?
right. Hello?
Hi, can you hear me?
Hi,
Yeah,
yeah,
hi.
we can hear you just fine. How are you?
I'm kind of confused. I have to write an equation that describes this information. You guys got something to write something down?
Sure. I guess I'll take this one.
All
All
right.
right.
Okay.
What is the information?
So there's two cars, an Edsel and a Studebaker, and they're 635 kilometers apart. They start at the same time and drive towards each other. The Edsel travels at a rate of 70 kilometers per hour, and the Studebaker travels 57 kilometers per hour.
All right.
And how many hours do the two cars meet?
I lost you there. Back up just a minute. So the two cars.
Yeah.
So two cars. Are they traveling towards each other?
Yes.
Okay, they are traveling towards each other. Oh, this is a rate problem. These are my favorite. All right. So
This is the standard torturous algebra problem that everybody always.
right, the two trains traveling towards
Right.
each other. When do they hit or something? Okay. All right. I'm sorry. So two cars traveling towards each other. They're 635 kilometers apart. I forgot that part.
Yeah.
Keep going then from the 635 kilometers.
So the Edsel's traveling at a rate of 70 kilometers per hour.
So I don't know what kind of car that is. What is it? Do you guys
It's
know?
an Edsel.
What's
Sounds like an
Edsel?
old car. I mean, a Studebaker is a pretty old car, so.
Okay.
Sure.
I'm going to call it car A. Can I do that? Car A.
Okay.
How fast is that traveling?
70 kilometers per hour.
And why? Okay. Per hour. Gotcha.
And I guess you'll call the Studebaker car B.
Sounds
It's
great.
traveling at 57 kilometers per hour.
Okay. Gotcha.
And it says, in how many hours will the two cars meet? I'm stuck on the whole thing because I don't understand this kind of problem.
Okay, how many hours? Okay, I think I can walk you through this. So how many will they meet? So we've kind of got to think about the situation, what's happening and what we know and what we don't know. And typically, part of the reason why I said, oh, this is my favorite kind of problem is because it's a distance, rate, time problem. Your distance in general is going to equal your rate times your time. And we're going to use this equation kind of as our model to help us write one equation for this particular situation. And here's what I mean. So you gave me the rate of car A, so I'm going to call it rate A, and that is equal to 70 kilometers per hour. You gave me the rate of car B, which is 57 kilometers per hour. The distance, let's say this, we'll say the time, we can say that the time of car A is, even though we don't know what it is, we know that it's going to be the same as the time of car B. So however long it's taking car A to get X distance is going to be the same as it is for car A for them to meet. They're going to be traveling for the same time period. Does that make sense?
Yeah, it would be hard to crash if they weren't in the same place at the same time.
That's very true. Exactly. So we know our time A is going to be equal to the time B. We also know our total distance is 635 kilometers. So we could say distance A plus distance B is equal to 635. And then I don't know if you've seen some of the information or some of the problems that have been going on here before, but we've been doing systems of equations. We can potentially use this information to get us a systems of equation. Our goal is basically to get one equation, one variable. And our issue is that we have three. So we could, here's my thought anyways, is I'm going to take this equation here, I'm going to solve it for t. So basically divide both sides by the rate. So we could call time is going to be equal to the distance times the rate. Does that make sense?
Yeah.
So you can kind of write that equation a lot of different ways, but we're going to use it in this form. For my time A is going to be equal to time B. So time A, I could say time A is also equal to distance A divided by rate A. Now we don't know distance A, but we do know rate A. So let's say time A is equal to distance A divided by 70. Then we could also say time B is distance B divided by rate B, which we also know rate B, which is 57. Actually, let's do this. Oh, we know time A is equal to time B, so I'm going to go ahead and say distance A over 70 is equal to distance B over 57. So I basically took this and said it was equal to this because the time of both cars, it's going to be the same. So now I'm going to take this equation. Let me kind of separate them here. This is not very neat, I'm sorry. I have that equation, and then I also have this other equation, dA plus dB is equal to 635. So wait, let me back up though really quick. Does that make sense, kind of what I did?
Yes.
Okay, you're following me so far?
Yes.
All right. And really, I'm kind of working this out as I go, and I don't know if this is just because rate problems are not my favorite. I tend to work them out as I go, and I play around with it. But that might actually be a good strategy to play around with, okay, I know this, I know this, I know this. How can I put that stuff together? That's kind of what I'm doing right now. I've gotten to the point where I have 2 variables, 2 equations, which is great. And I'm going to do the same thing that Nate was doing earlier in the show, where he took one of his equations, the simpler equation, and he got one of the variables by itself. So I'm going to look at my second equation. Since that's simpler, I'm going to subtract distance B from it and call it distance A is equal to 635 minus distance B. Then what I can do is replace in this equation up here, replace distance A with 635 minus distance B. So I'm going to do this over where I've got a lot of room here. 635 minus distance B over 70 is going to be equal to distance B over 57. Now, what was your requirement now? You just had to write an equation?
Well, we had to write the equation, yes. And that seems to do it.
So, I mean, and there are a bunch of different equations, but if you're looking for a way to write an equation that you can actually go and solve, this is one of the equations you could write. There are definitely more ways to go about this. This is not the only way, but your goal is to kind of get it down to where you have one equation, one variable, and if you can figure out one of those, you can kind of go back and figure out the rest of them. So this is one of the equations that would work.
Okay, thank you very much for your help.
No problem. I hope that made sense.
It did. Bye-bye.
Thanks.
Yeah, I think there are a lot of ways to do those problems. You can just manipulate a lot.
Yeah. And honestly, these are my least favorite problems, the distance, rate, and time.
Yeah.
And so you can kind of see someone who struggles with them, how to maybe struggle through it, if that maybe that helps.
Yeah.
Subscribe! Come on, push the button.
You know you want to.
Do it.